Good morning friends. In last two lecture of projection of line we solved three problems, okay, or three similar problems. In that problem true length is given, angle theta and phi is given, and position of A is given, means locus of A and radius is given. Okay, now from today we are going to solve some problem which have different condition. Okay, so before starting that problem I want to explain something at here. Okay, if you seen this problem carefully, what we done here. Okay, here after finding four locus, okay, after finding four locus for this length, okay, this true length means at here, okay, this true length I draw in vertical plane. Okay, so I take its projection in horizontal plane. Okay, so I get its top view length at here. Okay, for this true length I take its projection at here. Okay, so I get its top view length, but this is not my final top view. For finding top view I have two conditions for B point. Okay, its distance from A is this much, true top view length. Okay, and I get the B point on this line, this locus. So I take A as a center and top view length as a radius. I draw one arc which intersect at here. Okay, so here I get my point B here, so I find my final top view AB. Similarly, for this true length I take projection on vertical plane at here. Okay, so I get my front view length at here. Okay, now find final front view. For B dash point I have two conditions. Its distance from A dash is equal to front view length, and I get the B dash point on this locus. So I take A dash as a center and front view length as a radius. A dash as a center and front view length as a radius. I draw one arc which intersect at here. Okay, B dash point. So I get my B dash point at here, and I find my final front view at here, A dash B dash. Okay, an angle made by final front view is equal to alpha, this much. Okay, similarly here the angle made by top view is indicated by beta, inclination angle alpha and beta. Okay, let's see this problem. First I write the data. The line AB is 75 mm long, so its true length is given. True length is equal to 75 mm and has its end point A 15 mm above HP. So A point is 15 mm above HP and 10 mm in front of VP. 10 mm in front of VP. Its end point B 45 mm above HP and 50 mm in front of VP. 50 mm in front of VP. Okay, so here I have 5 data. Okay, now our method is same. First we find the 4 locus. After 4 locus from true length I draw the projection, and from front view length and top view length I draw the arc. Okay, so let's start. Okay, now first I draw the reference line XY. Okay, now I first represent point A. Point A is 15 mm above HP. So from here I measure the 15 mm distance. This distance is equal to 15 mm and 10 mm in front of VP. So from here I measure the 10 mm and draw one line at here. Okay, so I get my A dash point at here and A point at here. Okay, now first I draw the locus for A dash and A. So from here I draw one horizontal line. This is my locus for point A dash. Similarly for here I draw one horizontal line. This is my locus for point A. Now I come to the second point. For B point condition is 45 mm above HP and 50 mm in front of HP. Okay, at here I don't know exact position of the point B, but I know that it is 45 mm above HP. Okay, so from here I measure the distance 45 mm. Measure the distance 45 mm and draw one horizontal line. Similarly it's 50 mm in front of VP. Okay, so for this reference line I measure the 50 mm distance and draw horizontal line at here. So this is my locus for point B. Okay, this is my locus for point B dash. Locus for B dash, and this line indicate my locus for point B. Okay, so I get my B dash point on this line and B point on this line. Okay, this distance is equal to 45 mm and this distance is 50 mm. Okay, now my here true length is 75 mm. We have true length and final front view on the same line, same locus. Similarly here true length and final top view on the same line. Okay, so here I get the true length on this line, end point of the true length at here. Okay, so I simply, true length is given 75 mm, so I measure 75 mm distance. Okay, I draw one arc on this locus at here. Similarly, I take A as a center and 75 mm as a distance. I draw one arc at here. Okay, so here at this point I draw my true length at here, so I write down point B1 dash at here. Okay, so this is my angle theta. Okay, that the true length make with the HP. Similarly here I get arc at here. Okay, so I draw one line from A at here, so this is my true length 75 mm. Okay, and this angle is phi. Okay, that true length make with the vertical plane. Okay, so now I get the true length and 4 locus, so I complete the 4 locus. Now from true length I draw the projection. Okay, so now from true length I draw the projection up to locus of A. I draw the projection for this line A dash B1 dash. Get the projection of A dash point at here, so I take the projection of B1 dash on this line. Okay, so here I get my top view length. Okay, I here give the name B1. Okay, now from top view length I draw the arc. Okay, so I take A as a center and A B1 as a radius, because for indicate point B I have two conditions. Okay, its distance from point A is equal to top view length, and I get the B point on this locus. Okay, so I take A as a center and A B1 as a radius. I draw one arc here. I take A as a center. Okay, so I get my final B point at here. Okay, so this line AB is my final top view. Okay, similarly for this true length, okay, I take the projection. So from here I take the projection at here. Okay, I draw the projection for A B. Here I give the name B2. Okay, so I take the projection of A B2 line. Okay, on vertical plane. Okay, I get the projection of A point at A dash, so I take the B2 projection of point B2 up to this locus. Okay, so this is my final front view length. Now for finding the point B dash, I have two conditions. Its distance from A dash is equal to front view length. Okay, and I get the B dash point on this locus. I take A dash as a center and front view length as a radius. I draw one arc at here, so I get my B dash point at here. Okay, so A B dash is my final front view. Okay, an angle made by front view is called the apparent angle alpha. Similarly here, angle made by top view is called apparent angle beta. Here in question given that I determine the true inclination with HP and VP. Okay, so we require to find the theta and phi. That we get at here. Theta is equal to, if we measure the theta is equal to 23 degree. If I measure this angle phi, then it is equal to 30 degree. Okay, so this is the answer of our question. Under data that you get from this problem is apparent angle alpha and apparent angle beta. Okay, top view length and front view length. Okay, let's come to the next problem. Okay, let's solve this problem. First I write down the data. A line AB has its end point is 16 mm above HP. Point A is 16 mm above HP and 25 mm in front of AP. 25 mm in front of AP. The length of the line in the plane is 60 mm. Means plane length. I earlier said that the top view length is also called the plane length, and front view length is also called as a elevation length. Okay, so here plane length is given. The length of the line in the plane is 60 mm. So plane length or top view length is equal to 60 mm. Okay, the length of the line in elevation means elevation length or front view length is equal to 65 mm. The distance between the end projector is 45 mm. Distance between end projector means distance between line AA dash and BB dash or final line. Okay, so this distance is called the distance between end projector. Okay, so distance between the end projector is 45 mm. Okay, draw the projection of the line. Okay, so first I draw the given data. Okay, now first I represent the point A. Point A is 16 mm above HP. So first I draw the reference line at here. Now from reference line I measure the 16 mm distance above and 25 mm in front of. So 25 mm at here. Okay, so here I get the point A dash and at here point A. Okay, so first I draw the locus for A dash. This is locus for A dash and now locus for A. Okay, now the given another data is its front view length and top view length is given. Okay, it's 60 mm and 65 mm. Okay, and the another data is distance between end projector is 45 mm. Okay, so first here I measure the distance is equal to 45 mm. Here I measure the distance is equal to 45 mm. Distance is equal to 45 mm and draw one line. Okay, so I get my B dash point and B point on this line. Okay, because distance between the end projector is 45 mm. So distance between end projector means distance between line AA dash and BB dash. Okay, so I get my B dash point on this line and B point on this line. Okay, so I get the B dash and B point on this vertical line. Okay, now come to the another data. Here the plan length is 60 mm and front view length is 65 mm. Okay, so the front view length is given, okay, which is 65 mm. Okay, now so for finding the point B dash I have two conditions. Okay, here its length is equal to 65 mm, front view length is equal to 65 mm, means its distance from A dash is 65 mm and I get the point B dash on this vertical line. Okay, so I take A dash as a center and 65 mm as a radius. I draw one arc which intersect this vertical line at here. Okay, because this front view length is given, front view length is equal to 65 mm. Okay, and another condition is I get the B dash point on this vertical line. So I take A dash as a center and front view length as a radius. I draw one arc which intersect this vertical line. Okay, so here I get to my final B dash point. Okay, so this is my front view length. Okay, and this angle is apparent angle alpha. Okay, similarly here top view length is given 60 mm. So for finding the point B I have two conditions. Its distance from point A is equal to 60 mm. Okay, and I get the point B on this vertical line. Okay, so I take A as a center and 60 mm as a radius. I draw one arc which intersect this vertical line at here. Okay, so this is my top view, final top view. Okay, because top view length is equal to 60 mm, so I measure 60 mm length, and second condition I get the B point on this vertical line. So I take A as a center and 60 mm as a radius. I draw one arc at here. Okay, so I get my point B at here. Okay, so this is my final top view AB. Okay, now we require to find the true length of the line. Okay, here in this problem, if we see that if I have a front view length, okay, then I from front view length I draw one arc, and from arc I draw one projection line, vertical line. So here I get the point B2. Okay, so from this front view length I draw one arc. Okay, because we draw the arc from the front view length, so from front view length I draw one arc at here. Okay, here, so this is my, I give the name at here B2 dash. Okay, and now from this front view length I draw projection. up to the locus of B. Okay, here I draw the locus first, locus of B dash, and here the locus of B. Okay, because here we know that the B and B2 point on the same horizontal. Okay, because this distance from reference line is same. Similarly here B dash and B1 dash on the same horizontal line. Okay, so I get the end of top view length on this line. Okay, so similarly here I take the projection up to locus of B. Okay, so here I get my true length. Okay, and this angle is phi. Okay, similarly here from B point I draw one arc at here, so here I get the top view length. Now from top view length I draw the projection up to the locus of B dash. Okay, so here I get my true length, and this angle made by the line is equal to theta. Okay, here we get the true length, so you directly measure this true length, take as a radius, and from A dash you make the arc at here, so you also find the true length in this way also. Okay, because here true length is same. Okay, so here once we get the true length at here, then simply take this true length as a radius and A dash as a center. I draw one arc which intersected here, so I get this line also. I give the name at here B1 dash. Okay, and at here B1. Okay, here in the question given that find the true length of the line. Okay, so here if we measure this true length, then true length is equal to 77 mm. This distance, true length AB1 dash, this distance is also same. Okay, here I give the name B2. Okay, so AB2 is equal to 77 mm. Okay, and if I find it theta and phi, okay, theta at here, theta is equal to 40 degree. If I measure it at theta is equal to 40 degree, and phi angle at here, which make the true length with the vertical plane, phi is equal to 48 degree. Okay, so it is the answer of this question. Okay, here I explain again. Here we first find the front view length and top view length, which is given in question. Okay, so from front view length I first draw the one arc at here, so I get the front view length at here. Okay, so from front view length here B2 dash point I draw projection up to locus of B, so I get my B2 point, and I connect A B2, so I get the true length. Similarly for this top view length, first I draw the arc. Okay, so I get here top view length. Now from top view length I draw the projection up to locus of B dash. Okay, so here I get the point B1 dash. Now connect A dash B1 dash